Hello grade 8s and welcome to Geometry Proofs 2. In today's topic we start learning how to prove triangles congruent and how to look and see which parts of triangles will make them congruent. If you think back to when we first learned about congruence, we understood the word means something that is exactly the same. And it's important because we use a variety of different sources to understand how the symbol for congruence can change from country to country. In this country, you should use 3 horizontal lines, as shown here, but in other parts of the world, we use an equal sign and a squiggle on top, which means similar and equal or congruent. It's also important to remember the symbols that appear in diagrams. For example, in this diagram, AC is congruent to AB because of these lines, and angle C and angle B are equal because of these curved lines inside the angle. So it's important as we work through our problems that we can use the diagrams and the correct notation to generate our proof. In grade 8, we focus a lot on triangles that are exactly the same. And this really isn't about the importance of finding similar or congruent triangles in the real world. More, proving helps test your observation skills, and it tests your logical thinking skills. It's teaching you how to use evidence to make an argument. When we're trying to see if triangles are congruent, we're going to look at 2 different parts of the triangle. We'll look at the sides, and we're going to look at the angles. And in order for triangles to be exactly the same, certain criteria need to be met. The first case is the easiest for us to prove, and it's when we have 3 pairs of sides that are exactly the same. When we use the reason in a proof, we call it SSS for side, side, side. For example, in these 2 triangles, triangle ABC and triangle DEF, we have 1 pair of congruent sides, 2 pairs of congruent sides, and 3 pairs of congruent sides. So we can say that these 2 triangles are exactly the same because of the side, side, side rule of congruency. In the second situation that you can look for to prove triangles congruent, you need to look for 2 sides that are the same in each triangle. And then you need to look for an angle that's right in between those sides. So it's almost like you're looking for a V shape or one kind of vertex, like this situation I'm showing you in the diagram below. In this case, I've got one side that's equal on the left, another side that's equal on the right, and in between them, I've got an angle that is the same. When we abbreviate this, we call it side, angle, side, because we have a side, an angle, and a side that are the same in both triangles. In our third situation, to prove congruence, it's just the opposite of what we've done, where we have an angle, a side in between, and an angle. And we abbreviated ASA, and it's shown below, where we have 2 angles that are congruent on the left side, a side in between, and then 2 angles that are congruent on the right side. The fourth condition for congruence, the last one that we need to learn, is when we have a right triangle, which you might have called a right-angled triangle when you were in primary school. And it's important that we learn an extra word here, a fancy word called hypotenuse. The hypotenuse is the longest side of a right triangle, and it's always the one that is opposite or across from the 90-degree angle. In this particular set of congruence, the triangle must have 1 pair of sides that are the same, and it must have 90-degree angles. And then the hypotenuses must also be the same. If that occurs, it meets the 4th condition for congruence, and we abbreviate this as R for right angle, H for hypotenuse, and S for side. So to recap, there are 4 conditions to prove triangles congruent, and you need to memorize them so you can look for these parts and try to prove triangles congruent. The first one is side, side, side congruence, or SSS. Then we have side, angle, side, or SAS. Angle, side, angle congruence. And right-angled triangle, hypotenuse, and side congruence. So now let's put our knowledge to good use. The problem that's drawn here for you is very, very typical of a problem involving congruent triangles. And it's important we understand all of the notation and information so that we can solve a problem like this. These symbols here mean triangle, and the symbols here with the lines above them mean the sides. So that means side AE, which we can look for and find here, side AE, is equal to side EC, and it means side BE is equal to side ED. At the bottom, what we're supposed to prove, it means triangle AED, this one here, is congruent to triangle BEC, the one over here. So that's how we read and interpret this diagram, and we can get down to the business of proving these two triangles congruent. So in this problem, we've been given nearly all the information we need to solve, but we're still going to have to unlock one small thing to be able to solve and prove the two triangles congruent. We have to always think of our four conditions of congruence. We have side, 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 angle, side, angle, side, angle, and RHS for the right angled triangles. And what we do going from step 1 to step 2 is look and see what things we have in common and delete the things that don't make sense. So if we think about these two triangles, we don't know if there's a right triangle here, so we cross that out. It doesn't make sense. And if we look carefully at this problem, we can see we've been given some information where we have one pair of sides the same and another pair of sides the same. So if we're being logical, that option of angle, side, angle also doesn't make sense because we've already been given two sides that are the same. This now leaves us with two options, three sides the same or side, angle, side. And if we're not told that the other sides are the same, it's going to be really hard to prove that. There are some chances that it can happen, but it will be difficult. And it looks then, if we eliminate all of the possibilities, that we should be able to prove by side, angle, side. But if you've been paying attention, we have a problem. We're missing an angle. And we're going to have to figure out how to prove that the angle that's in between the pairs of sides is the same. And if you think back a few lessons, we learned a rule that will help us here. If we look very carefully at the situation, we have one angle on the opposite side of an X shape from the other. And if you remember, opposite angles are equal. And this means now that we can prove that this triangle on the left, AED, is going to be equal to the triangle on the right. And when we plan our proof, it's going to be important to prove things in order, so we're going to prove the sides, a pair of angles, and a pair of sides in order to prove that the two triangles are congruent. So let's get down to the business of proving. You'll remember when we started learning about proofs that proofs always need to be written out in a table where we state all the facts and we give reasons for what we're stating. It's also helpful but not required, if you wish, to give yourself some notes and organize your proof before you actually start writing anything. And in this case, we know we want to prove a side, angle, side in that order, and we want to be able to prove that triangle AED is equal to triangle BEC, and the reason we're going to use for that is side, angle, side. So we're ready to begin. It's always important that we start with where we are. And in this case, we are starting in triangles AED and BEC. Let's now complete this proof in a three-step process. In the first step, we will prove a pair of sides. In the second step, we'll prove a pair of angles. And in the third step, we'll prove the remaining pair of sides. In the given information for this problem, we are told about two pairs of sides. We'll use one first, it doesn't matter which, and then a second pair. So in the first step that I'm going to do, I'm going to say AE is equal to EC, and that was given to me, so that I can use that as a reason. And it means that I now have shown one pair of sides equal. Step 2 is the hardest, and I've used some new notation here. where I've used angle E1. This means angle E1, part of angle E, and angle E2. And we know those angles are going to be the same, not from anything that's been given to us, but because they're opposite angles. Finally, we know that BE is equal to ED. How did we know that? Well, it was given to us. So that makes it easy. All we have to do is write given. And this means that I now have proven a pair of sides, a pair of angles, and a pair of sides. So I can say, therefore, these two triangles are going to be the same because of side, angle, side. And that's all there is to it. This is a long lesson because it is complex, and you're going to need to learn the conditions for congruence and how to write formal geometry proofs that prove triangles congruent. Good luck!